In this video, you will learn how to solve inequalities. If you can solve an equation, you can solve an inequality because they are exactly the same with only one exception. The only difference between solving an equation and an inequality is when you multiply or divide by a negative number. When you do that, you must switch the inequality. So here is that concept illustrated. So here we have a true statement, 3 is less than 8. Now with equations or inequalities, I can add, subtract, multiply, divide, whatever I want, as long as I'm doing it to both sides. So here, if I wanted to, I could multiply both sides by a negative 2. Alright, if I do that, on the left side, I have 3 times negative 2, which is negative 6. On the right side, I'm going to have negative 16. Notice that this will now not be a true statement because negative 6 is not less than negative 16. Negative 16 is less than negative 6. So when we multiplied by that negative, it made this into a false statement. So when I multiply or divide by a negative number, I must switch the inequality. So instead of the less than sign, I now need to make it a greater than sign. So that is the only difference when you're solving an inequality statement. So for example, let's say we had 2x is greater than or equal to 10. I solve this the exact same way that I'd solve an equation. Here we have 2 times x, so to get rid of the 2, I need to divide. So I divide both sides by 2. On the left side I have x, and on the right side I have 5. So my answer is x is greater than or equal to 5. All right, example 2, however, is still the same solving, but here we will need to switch the inequality because we have a negative 2 times x, and to get rid of it, I divide by negative 2. So because here I'm dividing by negative 2, I will need to switch the inequality from a greater than to a less than. So on the left side, this will give me x. On the right side, I have 10 over negative 2, which is negative 5. But I need to switch the inequality from greater than to a less than. Example 3, we have 2x is greater than or equal to negative 10. So here we need to divide both sides by 2. And we have x on the left, negative 5 on the right. But here we're not dividing by a negative number. We're dividing by a positive 2. So no need to switch the inequality. It's going to remain a greater than sign. So my answer is x is greater than or equal to negative 5. Example 4. We have negative 2x greater than or equal to negative 10. To solve this, I need to get rid of the negative 2, and I do that by dividing both sides by negative 2. Now when I divide, the negative 2's cancel out. On the right side, negative divided by negative would give me a positive 5. So I have x on the left, 5 on the right, and because I'm dividing by this negative 2 right here, I need to switch the inequality to a less than or equal to sign. So my answer is x is less than or equal to 5. Example 5. Now we have x over 2 is less than 5. So here we need to get rid of the 2 with the x. And this is saying that we have x divided by 2. So to get rid of division, I multiply. So I multiply both sides by a 2, and the 2's will cancel. I have x on the left, and then 5 times 2, which is 10 on the right. So my answer is x is less than 10. Example 6. We have x divided by negative 2 is less than 5. So here we need to multiply by a negative 2 to get these to cancel. Multiply over here by negative 2 as well. So I have x on the left, negative 10 on the right, but because I am multiplying by this negative 2, I need to switch the inequality. So instead of a less than sign, it's a greater than sign. So my answer is x is greater than negative 10. So once again, the rule is if I'm multiplying or dividing by a negative number, I need to switch the inequality. Example 7. To get rid of the 2 in the bottom, I need to multiply both sides by 2. So to do that, that will cancel. X is on the left. Negative 5 times 2 is negative 10 on the right. But even though there's a negative here with the 5, I'm multiplying by a positive 2. So because I'm multiplying by a positive, there is no need to switch the inequality. So this would remain as x is less than negative 10. Here we have x divided by negative 2 is less than negative 5. To get rid of the negative 2 in the bottom, I need to multiply both sides by negative 2. So on the left side, the negative 2's cancel. So I have x on the left, then negative 5 times negative 2 is a positive 10 on the right. And because I'm multiplying by this negative 2, that is when I switch the inequality. So I switch from a less than to a greater than. My answer is x is greater than 10. Example 9. We have x plus 3 is less than 10. These are all solved the same way that we'd solve an equation. Here we are subtracting 3 from both sides to get rid of the plus 3. So my answer would be x on the left, 7 on the right, less than sign in the middle. So it's x is less than 7. And no need to change the inequality because I'm not multiplying or dividing by a negative. I'm subtracting, but that is not multiplication or division. So this would be fine as it is. Example 10. I have x minus 3 is less than 10. To get rid of subtraction, I need to add 3 to both sides. So we'd have x on the left, and then 10 plus 3 is 13 on the right. So my answer is x is less than 13. Example 11. We're getting into a little more difficult of problems, but the solving is the same as you would with equations. So here I need to simplify both the left and the right side. So here I have the 3 I need to distribute and multiply it by the 2 and the negative y. So 3 times 2 is 6. 3 times negative y is negative 3y. And then over here, we have a negative in front of the y minus 4. So we can think of this as a 1 being in front. So I have a negative 1 times y, which is negative y. And negative 1 times negative 4 is a positive 4. So we have negative y plus 4 on the right side. So from here, I can bring the y's to the same side. And the easiest way would probably be to bring the 3y over to the right. So if I wanted to bring that over, I can add 3y. And when I do that on the left side, negative 3y plus 3y would cancel. So I have 6 on the left, and then negative y plus 3y. We have negative 1 plus 3 would give me a positive 2y, and that is plus 4. All right, and then to finish this off, I do reverse order of operations. So I begin with addition and subtraction first. So we see the plus 4. I need to get this away from the y by subtracting 4. So that cancels. I have 2y on the right. On the left, I have 6 minus 4, which is 2. And now to get rid of the 2 with the y, this is 2 times y. So I do the opposite of multiplication, which is division. So I divide both sides by 2. I have y on the right, and then I have 2 over 2, which is 1 on the left. So here I have y is greater than or equal to y, and usually you put the y first. So the y first, the 1 second, and the sign needs to be facing the 1. So y is less than or equal to 1. Example 12, we once again need to do reverse order of operations. So all the steps are the same with inequalities as it is with equations. The only difference is when you multiply or divide by a negative number. So here it's tempting to look at the -1 and think we need to add that first, but that's not what we do because the division sign acts as a grouping symbol. So all of this on the top is as if it's in parentheses. So we do the top last. All right, but the -2 in the bottom I can get rid of. So I can move that over, and I do that by doing the opposite of dividing by -2, which is multiplying. So I multiply both sides by -2. When I do that, the -2's cancel. I have 3x minus 1 on the left, and then 5 times -2 is -10 on the right. So notice I'm multiplying by a negative. So that is the one time when I need to switch the inequality from a less than to now it's going to be a greater than. So from here, I can continue with reverse order of operations. We have 3 times x, and we have a -1. Well, subtraction we would do first. So get rid of the -1 by adding 1 to both sides. When I do that, the -1 and +1 would cancel. I have 3x on the left, and then -10 plus 1 is -9 on the right. And then to finish off, here we have 3 times x, so I get rid of the 3 by dividing. When I divide, we now have x on the left, and then -9 over 3 is -3 on the right. And even though there's a negative here, I'm not dividing by a negative, so my answer would still be with the same inequality sign. So it's still going to be x is greater than -3. Now as we finish, there are some special scenarios to be aware of. So here, for example, we have an inequality and we're told to solve this. So we want to simplify this right side by distributing. So we multiply 3 by x and then 3 times -2 to get 3x minus 6. All right, then if you want to bring the 3x over here to the left side with the other 3x, I'd have to subtract. And when I do that, it cancels on the right, which is what I wanted, but on the left it also cancels. 3x minus 3x is 0. So I have this weird statement where it says 0 is less than -6. So this is a false statement, right? 0 is not less than -6. If you get a weird statement like this, where the variables are gone and it's not a true statement, then that means that there is no solution. If there's no solution, there's also no graph. All right, and the no solution symbol, if you wanted to write this in math notation, is a 0 with a line through it. That means no solution. One other special kind of situation that you might see is if you solve and get all the way to the end and it's a true statement. So instead of 0 is less than -6, let's say you had something like 4 is greater than or equal to 1. Okay, that is a true statement, right? So if you get the same kind of thing but with a true statement, then that means there is an infinite number of solutions. So what we'd say is that our answer would be all the real numbers. And the shorthand way of writing this in math notation, instead of writing our answer as all real numbers, we use a fancy R like this, and that means all real numbers. So be aware of those two special scenarios. And that concludes our lesson for today. We will see you next time.